Hello everyone, welcome to this video where we are going to dive into kth largest sum in binary tree. So what is happening is that you receive as input a binary tree and you're supposed to kind of store all of the sum of element of each level, and at the end you return the kth element. Like when you sort, if k is equal to 1 you return the biggest element, if k is equal to 2 you return the second biggest element. So you got the point. So you are going to sort the array into decreasing order and you return the element at position k. Now for us to solve this, we are going to really go into a straightforward approach, which is transform the tree into array where each of the element is the sum of that level. After that, we are going to sort our array, and after sorting the array we are going to return the element at a given position. Yeah, that's how we are going to operate. So for us to now transform the tree into an array, we can use a while loop or we can use recursion. I'm going to go with a recursion approach here, and my approach will be like this. I know that I'll have a kind of helper function which will help me to do that, and the helper function is going to take the root and the jeep. Initially the root is at the jeep or the level 1, so I'm going to call it this way, and I'm going to have a global variable here which is my vector, and I will call it let's say result. Yeah, let me call it this way. And what I will do here, my helper function will be a void because it will not return anything. The helper function is going to take a tree node that we'll call root and a jeep, int jeep. So the idea is that if the element you are receiving is at jeep 1, you increment the value at the index 1 minus I minus 1 into the result, because the result is actually 0 base. So the element at position 1 is going to be stored at index 0, element at position 2, and so on and so on. So basically what will it look like? So we can say if the root is actually equal to null pointer, what we do here is that we return there's nothing we will do. If the root is null, that means if you are here when you are going to return, this will be null, this will be null. Or if you want, you can even check before returning, so it depends on you to not have this condition here. But me, it's okay for me to have this, and after this I will check. Now if now the result dot size is actually less than the jeep, that means we are trying to add an element with a jeep that's not actually present. And since we are moving incrementally, we are never going to find ourselves trying to add element at jeep 2 if we haven't add element at jeep 1. So if you want to add an element, that means maybe jeep 2 which doesn't exist, that means we need to create that step. And we are 100% sure that it's not like we are going to find ourselves trying to add element at jeep 5 whereas there are no element at jeep 2, 3 and 4. So if you want to find your element, if you find yourself trying to add element at jeep a, that means a minus 1 already exists, so you shouldn't worry about that. So for this, what you can do is that you can just say if you find yourself in this situation, you can just say result.push back of 0, you add 0 here, and after this you continue your natural process. And the process here is to set result now dot result of jeep minus 1 plus equal to the root dot val. That means no matter what will happen, if it's something that already exists, this will exist. If it's something that doesn't exist, you are going to create it here with a pushback, and now you'll be able to do so. And after this, you just need to call the helper now on the root dot left with the jeep plus plus, and then you do the same for jeep dot right. We are moving one step down. So after calling this, it will build this. So after calling that, I will have this. The next thing I need to do is the sort. How do I sort? So I will just sort my array of result dot begin and the result dot end. And then since here I want to sort in decreasing order, I should pass like a custom function here. I can pass a custom function or just pass something like this, it will be okay. So after this, I'm here, so I have my array sort like this. And what I need to do, I need to return now the result of k minus 1. Yeah, this is it. So let us run and see. Okay, we have an error somewhere. Okay, we are doing something which is not okay. Oh, I get the idea. Maybe we are trying to access element that doesn't exist. Yeah, that was it. We are trying to access element that doesn't exist. Why? Because we are missing something here. Return the k largest level sum in the tree, not necessarily distant. If there are fewer than k level in the tree, return -1. So in this scenario, we can find ourselves with a k which is greater than what we can have in our result array. So we're just gonna say if k is actually greater than the result of size, what we are going to do is that we are just going to return -1, and only otherwise we return this greater or equal. So let us run again. Okay, it's working. Let us submit. Yeah, we have a wrong answer for this one, -1. If k is actually greater, why greater? Because we are accessing k -1. If you just say greater or equal, that means if you want to if you have an array of 5 element, you want to return the fifth element, it will fail, which is not okay, because the fifth element corresponding to the element at position 4, which is actually valid. So you should have equal here. You should have greater here, not greater or equal. Yeah, perfect. So this is my approach of solving this. I hope you do enjoy it. Feel free to give me any input. I'll be really happy to interact with you regarding this. See you tomorrow for a new challenge. Ciao.